Okay, we've been working on properties of exponents, and now I want to address when you have special bases, uh, specific bases, what is the rule? So if you have 0 to the x power, or 1 to the x power, or negative 1 to the x power, well, when you're in class, most of the time when you're dealing with the properties of exponents and logarithms, you won't have these bases. This is why. Well, 0 to the x power, well, how do you raise nothing to something? It's always a problem. How do you raise nothing to a power? If you have nothing, it doesn't matter what you do to it. You can multiply, divide, add, subtract. Well, I shouldn't say add, subtract. Multiply, divide, raise to a power. If you have nothing, you're still going to have nothing. 1 is a very unique number. It's not prime, it's its own specific type of number, its own identity. No matter what you do to 1 in terms of multiply, divide, raise to a power, it's going to be 1. 1 to the second, 1 times 1 is 1. 1 to the negative second, 1 over 1 squared is still 1 over 1, which is 1. So when we're doing these math problems in class, rarely are you going to have, or I should say never will you have 0 to an exponent or 1 to the exponent. The other thing that you're not going to have when we're working with properties of exponents and logs is a negative base. And this is why. A negative number raised to a power is problematic. It has inconsistent results. So for example, negative 1 squared is equal to 1, but negative 1 cubed is equal to negative 1. So the results are inconsistent. So these are the 3 special bases: 0, 1, and any negative number. These are bases you typically are not going to be dealing with in a high school algebra course at any level. Algebra, Algebra 2, pre-calculus, calculus. All right, that's it for properties of exponents, special bases.